Okay, so we want to look today at balancing redox reactions. Now, not all redox reactions are straightforward to balance. If they are synthesis or combustion or single replacement or something you've seen before, yeah, those are easy. You know how to balance those. But there are some more complicated reactions that take place in acidic solution that you can't just balance using coefficients like normal. You have to do a little extra to balance it. You have to look at the electrons. So to do this, we're going to have to split our reaction up into half reactions and show those electrons that are being oxidized and reduced. And there's a very specific method that you have to follow to make this happen. So this is the example we're going to use. Sulfur plus nitrate is going to yield sulfur dioxide and nitrogen monoxide gas. So when you start balancing, the first thing that you might want to do is assign oxidation numbers and determine what was oxidized and what was reduced, if that's what the question calls for, and you know how to do that from the last video. So we're actually going to start with number 2 today. We're going to split this up into half reactions and then follow all of our balancing steps to get a balanced reaction in the very end. So the first thing we want to do is separate it into half reactions. How do you know what the half reactions are going to be? Well, I would guess that the things with sulfur are going to be in a half reaction, and then the things with nitrogen are going to be in a half reaction. So those are what we're going to split apart. So we're going to say sulfur yields sulfur dioxide, and nitrate yields nitrogen monoxide. Okay, and obviously those aren't balanced. That's what we're working on. So, to begin with, once we have our half reactions, we're going to balance all non-oxygen and hydrogen atoms. So that means we're looking at the sulfurs and we're looking at the nitrogens. They seem to be balanced. So we move on to the next step, was to balance the oxygens by adding water. So in our first half reaction, we have 2 oxygens here, but we don't have any oxygen over here. To remedy that, we're going to add 2 H2Os. Okay? Now, in the second half reaction, we have 3 O's on the left, but only 1 on the right. So we're going to add 2 H2O to this side. Now, the reason we can add water is because these things are aqueous. Water is present when the reaction starts, so it can be used in our balanced equation. All right, so now we've just created hydrogens that don't have anything to balance. So our next step is to balance hydrogens by adding H+. H+ ions are present in acidic solutions. That's what makes something acidic. So they are there as well because this is happening in an acidic solution. So for our first half reaction, we have 4 hydrogens. So we're going to add 4 hydrogen ions on the other side. Same thing for the second. We have 4 hydrogens. So we add 4 hydrogen ions on this side. Okay. Now, here's the most complicated step. Number 6, balance the charge by adding electrons. Remember, one of these is oxidation and one of these is reduction. So something has to be gaining and something has to be losing electrons. And we figure that out by looking at how the charges change. So if we look at our first half reaction, this whole left side doesn't have a charge. So that means we're going to have to make this side have the same charge as over here. And to do that, we can only add electrons. We can only add negatives. So on the right side, we have a charge of +4. So to make it the same as the other side, we would add 4 electrons. So now both sides are equal to 0. Okay. In the second half reaction, we have +4 minus 1 equals +3, and on the right, our charge is 0. So to make +3 equals 0, we're going to add 3 electrons on the left. Now we have oxidation here, because we're losing electrons, and reduction here, because we're gaining electrons. Now, we have a problem. We're not gaining and losing the same number of electrons. So we have to multiply each reaction by some number to get the electrons gained and lost to be the same. So if we have 3 and 4, then that could be 12. So we're going to multiply this first reaction times 3. And the bottom reaction times 4. Now this is where we rewrite with our new coefficients. So our first half reaction we rewrite. Scoop this up a little bit. We're going to have 6 waters plus 3 sulfurs yields 3 SO2 plus 12 H plus 12 electrons. And our second half reaction, we're going to have 12 electrons plus 16 hydrogens plus 4 nitrates yields 4NO plus 8 H2O. Okay, now the next thing we want to do is put the reactions back together. So we're going to add these. And when we add them, we can cancel things that show up on both sides, okay? So that means we can cancel our electrons because they show up on both sides. That was the point of the multiplying. We can also cancel all of those waters and have 2 left there. We can cancel all of those hydrogens and have 4 left there. Now we combine everything that we have left. So we're going to have 3S plus 4H plus 4 nitrates yields 3SO2 plus 4NO plus 2 H2O. Okay, so that now is our balanced redox reaction, and we couldn't have done that without adding the hydrogen ions and the water molecules. So it ends up balanced, but it has to go through that very distinct process to become balanced.